You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your IT fundamentals certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. In this episode, we explore two foundational concepts that help bridge the gap between human thinking and computer instructions, pseudocode, and documentation. These are not actual code elements that a computer executes, but rather tools for understanding, communicating, and planning logic in programming. For those preparing for the Information Technology Fundamentals Plus exam, grasping these two tools is essential. You will not be asked to write pseudocode or generate documentation yourself, but you must understand what they are, what they look like, and how they support the software development process. This topic falls under Domain 4 of the Information Technology Fundamentals Plus exam, which focuses on programming logic and organization. Questions on the exam may present short examples of pseudocode or ask you to identify the role of a particular documentation type. It is more about recognition and purpose than about writing. There is no need to memorize any syntax or formatting rules. The exam expects familiarity with what pseudocode and documentation are and how they relate to readable and maintainable code. Pseudocode is a way to describe a program's logic without using actual programming language syntax. It is a simplified, plain language representation of what a program is intended to do. The goal of pseudocode is to focus on the logic, not on the technical specifics of any particular language. Because of this, pseudocode can be read and understood by anyone familiar with basic logical structures, even if they do not know how to code. It acts as a bridge between human reasoning and formal programming. The main purpose of using pseudocode is to help visualize the logic of a program before writing real code. This is especially helpful for beginners or for those working in teams where clear communication is essential. When a developer outlines a plan using pseudocode, it allows others to review the logic and make suggestions without getting distracted by syntax details. It also serves as a tool for organizing the overall structure of a program before diving into a particular programming language. Pseudocode typically follows a predictable structure that mirrors logical steps in a program. Common terms you might see include if, then, while, do, and print. These words are easy to understand and focus on the conditions and actions a program must perform. Pseudocode does not require punctuation, indentation, or formatting rules. It is intended to be simple, clear, and readable, with each step laid out in sequence using everyday logic. Let's look at a few examples of pseudocode to see how it works in practice. One example might say, if score is greater than 90, then print A. This is not real code, but it is clearly describing a decision based on a condition. Another example might say, while count is less than 5 do increase count by 1. This expresses a loop in logic. These examples show how pseudocode can clearly represent logical decisions and repeated actions without needing to follow the strict rules of a programming language. Documentation in programming refers to written materials that explain parts of the code, logic, or design decisions behind a software program. It plays a vital role in maintaining, understanding, and improving software over time. Documentation can appear as internal comments within the code or as external documents such as user manuals or development notes. It helps both the original programmer and others who may work on the code in the future. There are several types of documentation used in software development. One common form is the inline comment, which appears within the source code to explain what a specific part of the code does. Another type is the user guide, which helps the end user understand how to operate the software. A third type is developer notes, which document how the program was built and provide context for future developers who may modify or troubleshoot the code. Within source code, comments serve as embedded notes that explain the purpose or function of a specific code block. These comments are ignored when the code is executed, meaning they have no impact on how the program runs. They are simply there for clarity. Different programming languages use different symbols to mark comments. For example, in some languages, 2 forward slashes indicate a comment, while in others, a number sign is used. These symbols tell the computer to skip over the comment. One of the major benefits of good documentation is that it helps others understand or revise the code more easily. When code is clearly documented, there is less risk of confusion about how it works or why certain choices were made. This is especially useful during debugging when a developer needs to trace errors or unexpected behavior. Documentation also improves clarity for reuse, allowing code to be adapted in other projects without needing to be deciphered from scratch. On the Information Technology Fundamentals Plus exam, you will be expected to recognize what pseudocode looks like and understand the general purpose of documentation and comments. You will not be asked to write any pseudocode or develop full documentation sets. Instead, the exam might show you a short passage and ask whether it represents pseudocode or a documentation example, or it might ask why a comment would be added to a specific line of code. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Understanding when to use pseudocode is an important aspect of planning and organizing program logic. Pseudocode is most often used before any actual code is written. It serves as a blueprint for the development process. It can also be used when explaining a programming concept to others, such as team members, instructors, or stakeholders. Because it is not tied to any specific programming language, it makes logic and intent easy to communicate. Pseudocode is especially useful as part of the technical design phase when outlining how a program should behave. Documentation, on the other hand, is typically created during or after software development has begun. Developers might add comments to code as they write it, or return to add notes later when updating or debugging. Documentation is not a one-time task. It is an ongoing process that continues throughout the life of a software project. As new features are added, bugs are fixed, or logic changes, documentation helps preserve the knowledge needed to understand what the software does and why it was designed a certain way. It is also important to recognize the differences between actual code and pseudocode. Real code follows exact syntax rules and can be executed by a computer. It includes punctuation, data types, operators, and other required components. Pseudocode, in contrast, is descriptive and non-functional. It is meant for humans, not machines. The exam may show you two different examples and ask which one is executable code and which one is pseudocode. Being able to distinguish them is key to answering such questions correctly. One of the defining features of pseudocode is that it does not follow any strict syntax or formatting rules. There are no required symbols, indentation levels, or standardized language structures. This makes pseudocode flexible and adaptable to different teaching and planning styles. The main requirement is that it remains clear and readable. The focus is always on the flow of logic, not the appearance or adherence to formal rules. This flexibility makes pseudocode a powerful tool for conveying ideas before actual development begins. Documentation is often stored in multiple places depending on its type and purpose. Inline comments are stored directly in the source code file. These are quick notes that describe specific code functions and are written alongside the relevant code. Broader documentation may be stored in separate documents, such as a README file that explains how to install or use the program. Other documentation can be found in help files or user manuals that accompany the software. Each location serves a different audience and purpose. Some key terms from this episode include pseudocode, comment, and documentation. These words are often used together but serve distinct roles. A comment is a note within the code. Documentation can be a broader set of written materials. Pseudocode is a planning tool that outlines logic. Additional terms include inline comment, which refers to a specific type of documentation, and instruction or description, which are common elements of both comments and pseudocode. Understanding these terms is critical for exam success. The exam may include a variety of question formats that test your understanding of pseudocode and documentation. One common type of question might ask you to match a description or example to the correct term, such as identifying whether a text block is pseudocode or documentation. Another format might ask you to choose why comments are used in source code. A third format could involve identifying the purpose of pseudocode based on a scenario or selecting the correct definition of documentation. It is equally helpful to know what is not tested on the Information Technology Fundamentals Plus exam. You will not be asked to format documentation according to any specific style guide. You will also not be required to write pseudocode with perfect structure or syntax. The exam does not focus on production-level documentation or programming experience. Instead, the focus is on recognizing these tools, understanding what they are used for, and distinguishing them from each other when presented in multiple-choice format. Pseudocode and documentation also connect directly to earlier topics you may have studied in Domain 4. These tools reinforce concepts related to logic flow, programming decisions, and software structure. Pseudocode complements loops and conditional statements by helping visualize how they should behave. Documentation supports readability, especially when functions or logic become more complex. Together, they make programming more accessible, maintainable, and understandable across teams and timelines. To summarize, pseudocode is a plain language tool used to outline program logic before actual code is written. It does not follow strict rules and is intended for human understanding. Documentation, in contrast, explains code after it has been written, helping others understand its structure, purpose, or operation. Both pseudocode and documentation are crucial for developing quality software, and both appear in the Information Technology Fundamentals Plus exam as recognition-based topics. Understanding how they support software development will help you perform well in Domain 4 and beyond. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.